Welcome back, folks, to the Technical Update series on Get a Grip on Lighting. Today's show, we're talking about Germicidal Ultraviolet Disinfection, GUV lighting. That's right, we're going to get into it with, guess who's back? Gabe Arnold. That's right. Gabe is a senior lighting engineer with PNNL. He has served for over 20 years' experience in lighting and energy efficiency industries, improving technology performance and accelerating technology adoption. I think we called him the lighting prophet once. He is a principal investigator on the advanced lighting team supporting the U.S. DOE's lighting R&D and commercial buildings integration programs, focusing on development and deployment of emerging lighting and building technologies. His current work focuses on germicidal ultraviolet lighting technologies, improving environmental sustainability, and the DOE's L Prize competition, which we talked about last time. Jason, can you say your last name for me before I mess it up?
Tuenge.
Jason Tuenge joined PNNL in 2008 as a lighting research engineer with broad experience in the lighting domain, ranging from applications engineering for a luminaire manufacturer to lighting design and engineering firms. His recent work has included characterizing the energy performance of connected lighting systems, developing guidance on calibrating measurement equipment, that's interesting, and leading radiometric and electrical testing of germicidal ultraviolet products through DOE's Caliper program. He has a BS in architectural engineering from the University of Colorado at Boulder and a Master of Information and Data Science from the University of California, Berkeley. We'll have some LinkedIn handles on the website if you want to click and connect with them. But for right now, we got to go quickly, Greg. Not quickly. We got to take our time. Whatever happens, happens. We got to go to thanks. Got to give thanks to our sponsor, Cooper Lighting. Go to COOPERLIGHTING.com, Greg Eric.
That's right. And Cooper Lighting Solutions Fail-Safe brand provides simple solutions for complex spaces. That's including healthcare and education applications. The Fail-Safe product line includes UVC disinfecting fixtures that use ultraviolet radiant energy to inactivate bacteria, mold spores, fungi, and viruses. The UVC fixtures are available in wall or ceiling mount options, and lab tests have shown that the light source inactivates 99% of the SARS-CoV-2 virus on a surface with an exposure time of only 9 seconds. Now, if you're going to get into this GUV lighting, go with someone you trust. And I'm telling you, Cooper Lighting is a company that you can trust. They've been around a long time. They do all the testing. If you go on that website and check out the Failsafe brand, you'll see everything you need to know about UV lighting. Trust them. Check them out.
It kills tuberculosis too, I'm sure. And a whole host of other things that are out there and going to get us. Go to COOPERLIGHTING. That's cooperlighting.com. Check out their line. It's their line of Failsafe. I like that name too. Well, welcome to the back, Gabe Arnold, and welcome to the show, Jason. You say your own last name.
Tuenge.
Thank you.
It's a risky one. People have had fun with it in the past.
Kind of kick it off here. And Gabe, I'm going to go to you because you're senior vet of the Get a Grip on Lighting show at this point. So UV lighting, it's been around a long time. I'm not saying GU, I'm just saying UV right now. UV lighting, it's been around a long time, but it feels new. It's like it's starting over. And I don't know if it's because of LED, but then at the same time, when we look at companies, half of them aren't even using LED technology when they do it. They're still using the old technology. So it feels new and there's a push for it. And we understand part of the reason why, but is it here now? Is it here to stay? Is it something that we're going to actually be actively selling?
I think, yes, I do think it's here to stay. I kind of feel like we're at the beginning stages of this technology. You know, the pandemic came along and it brought all this new attention on the technology, and there was a big rush to develop product and get it out there. But I kind of feel like the science wasn't quite there for it at that point, and we didn't know quite enough about it. And all of that is coming into view now. We've got some new research that we'll be publishing, and I think it strongly supports that this technology's definitely got a role to play, probably long into the future.
Jason, any thoughts on that?
Yeah, I mean, I think there's kind of a tendency to think that the current pandemic is mostly over or already over, but I think a lot of this is going to come down to preparedness for the next one. And, there is a lot of history behind germicidal ultraviolet. for things like TB. So we do have some standards in place to look at the efficacy of treatment as well as the safety aspects. But from what we've seen, there's not a whole lot of test data, product data, et cetera, out there to date. So yeah, that's something we want to see improve.
When we first talked about this when the pandemic kicked off, and I have a point, I'm just going to save it for a bit because I wonder if you guys are going to get into it on your own, but I've squared it out on my sheet here. But before we get there, like this idea that this is for pandemic preparedness or the next pandemic, I'm going to push back on you, Jason. I'm going to say this makes sense all the time. Like there are certain applications to me that, train stations, and these areas, it doesn't matter if there's a pandemic or not. I mean, we should be using especially active or passive air disinfection all the time in these places. It's just, if not already, I mean, a lot of places ended up already having that technology in place in their HVAC. It could have been expanded. So I'm going to say, I don't think it's for the next pandemic or, this pandemic. I think it's just it's something that makes sense in some applications. It seems to be a no-brainer to me. Am I wrong on that, or like I just pushed back on you right off the show here, but there's some applications that I just think there should be regulations about having this kind of thing.
Well, yeah, and I think there definitely are some applications where it can make sense. The trick with this is always, nothing is free. The first thing that springs to mind is energy. The next one is, degradation of materials. And so, assuming that everything's being done safely, then that's not really a big concern. But there is energy and there is degradation of materials potentially. And so, yeah, I think it always comes down to balancing risks, mitigating risks. Sometimes when you try to fix something with one solution, you introduce other issues. So it's just always a little bit of give and take.
Back to you,
there's
Greg.
niche.
Oh, go ahead, Gabe.
I was just going to add, there's niche applications where it has been used for a long time continuously. I think healthcare applications is one example of that. This has been used in hospitals for a long time, and they use it to clean operating rooms, for disinfect operating rooms, for example, between operations. I think that one thing the pandemic has done is kind of raised awareness with people about the cost of people getting sick and the spread of colds and viruses and sicknesses. And a lot of us have experienced that, acutely from COVID. If you've got kids, you've experienced it with your kids being out of school, and then that affects your ability for being able to work. And I think that that's probably going to create more motivation for using it, and more of these common applications that you talked about where historically it really hasn't been used.
What's interesting is I'm going to read my note that I wrote down when you guys started. So at the beginning of the pandemic, it seemed like everything was, when people thought COVID-19 could exist on surfaces. Okay, there was like this bonanza of equipment that came out with surface disinfection. Okay. And even Greg so I cut up a couple POs from customers for these like robots or whatever that people put in rooms. And, surface disinfection is actually pretty dangerous. You got to know what you're doing. There should be some training with that. But it seemed like once the surface thing came off the table, and maybe I'll throw this over to Jason first. Once the surface thing that, cleaning your orange with a bleach is not going to prevent a respiratory virus from, getting you. It seemed that it just evaporated off the table. Like once you couldn't clean surfaces anymore, nobody wanted UV. That's kind of how it kind of seemed to me in the trenches when talking to people. Well, actually, it's better in the air and it's best in the HVAC, like you said about deterioration of materials. Can we, put it in the outlets of the HVAC? We'll do a lot for this. And no, we're not interested in that. If there's no robot going around shining purple lights on people, and so it kind of occurred to me that it was almost one of those. A theatrical thing. We're pushing this robot around, and when the thing that actually worked, which was the active and passive air disinfection strategy, people didn't latch onto it at all, Jason. It was not sexy at all. The surfaces were sexy, but the air wasn't. I don't know why. Did you guys have any experience with that kind of feeling?
And there's the doors that you would walk through, the gateways.
Yeah.
A little controversial.
Yeah.
Well, I mean, I think, science is always a process, right? And so I think, it's always easy to look back and say, well, that was silly. Sometimes as you go through some of this process, things do seem silly, and sometimes our instincts are right. We think, it's probably spreading through the air. And then lo and behold, we decide that it was. So I think some patience is required with some of these things as we try to rule out possible, means of spread. But I think it is, as we learn more, going to come down to each different pathogen that we're really most concerned in at the moment and in that application, right? And so, like Gabe said, in hospitals, it's going to be pretty much all the time. But then in other applications, you might say, we probably don't need it right now, and then something else starts to bubble up, and we say, okay, now how does that thing spread? If GUV is not going to have any effect on that thing and its mechanism of spread, then don't use GUV. Use something else. So yeah, I think surface treatment absolutely still makes sense for certain pathogens, but it does seem like now that that doesn't really apply to COVID as much.
Yeah, but that's what people were latching onto from the sales perspective. You
Mm-hmm.
understand? Like they wanted to burn those surfaces free of COVID with any way they could. And as soon as that was off the table, I went to clinics. I went to a doc. The time when you can't go to the doctor when you're sick. Everyone remembers that time in COVID, right? Don't go to the doctor's office when you're sick. It's like, what? So I'm standing outside the doctor's office, and they're measuring everybody's temperature. And if you're sick, you're not allowed to see the doctor, right? And I went in there and I said, you guys, for $5,000, you can put an active UV system in your waiting room. And that would solve a lot of, I mean, it wouldn't kill everything, but it would actually help reduce somebody who's sick, get rid of those germs in the air instead of making people wait on the stairs outside.
Well, so I guess what we might be getting to here is just basically the potential for stigmas already setting in or preconceived notions of safety, right? So
Mm-hmm.
there's probably a perception that if you're hitting something else with UV, it's less harmful to you than if you have it moving around in the air, more of an ambient treatment. So that's definitely understandable where people would be more concerned about that. And I would guess maybe that's the underlying thing. And then again, this comes down to education and then also following through and making sure we're doing the right thing and not hurting people.
Like
So,
a walk-in clinic, Gabe, I'm going to go over to you in here. A walk-in clinic with a active air disinfection system, which, no one's going to jump up there and put their hand above the light.
mhm.
I think that would be effective. And if we added some theater to the fixtures, Gabe, where it said disinfecting, the little green light was on, showing people that this is what this is, in certain applications would go a long way to both disinfecting the air and, like you said, making people feel safe. Like safety is not a thing, it's not really a proven thing. It's a feeling people have, right? They feel safe or they don't. It's not actual. So I think there's a lot of applications where this should just make tons of inroads, and I could never get any traction. I must have quoted 50 jobs, Gabe.
Yeah, I think it's still early days with this, and education is needed, and we just haven't really had the knowledge quite yet. It's coming into view now, and we haven't been able to educate people about it. And the issue is that people haven't really understood how effective this could be. So let me tell you a little bit about what we've been working on. There's Since the pandemic, energy use, HVAC energy use in commercial buildings is actually up, and it continues to be up. And this is despite the fact that buildings are only partially occupied. And the reason for that is because many commercial buildings have implemented a series of recommendations that were made by ASHRAE and supported by others. That's the American Society of Heating, Refrigeration, and Air Conditioning Engineers. And they set the guidelines or standards for how much ventilation you should provide in buildings. So as a result of the pandemic, they came out with these recommendations that were basically all around increasing your ventilation. They recommended that you increase the amount of outside air ventilation into your building, recommended that you actually turn off or disable demand controlled ventilation. One of the energy saving strategies that we use in buildings for ventilation is that you actually put in some CO2 sensors that are measuring how much people are exhaling in a space and use that as a proxy for how many people are in. And then you can tune down your ventilation to meet the actual need instead of, constantly ventilating and assuming a building is always occupied. So they recommended that you turn that off, and then they recommended that you install improved filters, MERV 13 filters or better. That's how they rate filters. All of these things had a huge impact on HVAC energy use, especially bringing in more outside air. When you got to bring in that extra outside air, you're going to have to heat or cool that, and that's going to really jack up your energy costs. And so the Department of Energy, we were talking with them about it, and they funded us to do some work to look into this. We've got this GUV technology that we know can be, has an effect on neutralizing viruses, but we don't know really how effective is it compared to these HVAC strategies, these ventilation strategies that everybody's doing, and how does it compare in terms of its energy use? And so we've been looking into that. What do we know? There's lots of people studying this about how effective GUV is compared to the HVAC measures. How much energy does it use? And we're actually just publishing a paper this week. It's being presented at a conference by another one of our colleagues, Bilal Abushi, which did a deep dive review of all the studies that are out there. How does this GUV compare to these other ventilation strategies? And virtually all the studies that we looked at support that GUV is both more effective and more energy efficient than these other ventilation measures. That information has not gotten out to people yet. Right now, all they knew to do is what's been recommended by ASHRAE and others to ramp up your building ventilation. And I think that once people start to realize that, no, actually GUV can be a much more effective strategy for keeping people from getting sick or from getting COVID-19, and you can do it potentially at a fraction of the energy cost, I think that's going to be a big value proposition that will help support the adoption of this in buildings.
The filter thing, correct me if I'm wrong, but I've seen some things come across that say these filters do not filter COVID-19. It goes right through the filter. And so there's some dispute there because a lot of classrooms in Toronto were putting in these filters in the corner, expensive units to filter the air throughout the classroom, and they thought under the presupposition that it was capturing COVID-19. No, it's capturing mold spores and fungus and all this kind of stuff, but it was unclear about whether it was deactivating the COVID-19 virus or even able to capture it. And so I'm gonna, I don't think that the filter issue is something that is going to prevent these airborne viruses, if that's what we're talking about. Yes, mold and fungus and all those kind of spores, they're much larger. They get caught in a filter. COVID-19 will just go bounce off the different things and go right through. So maybe, or I could be wrong about that, but that's what I have read about specifically on that.
The studies do support that improved filters work as you go up, and the rating on your filter, it basically catches smaller and smaller particles, and you go all the way up to HEPA filters, and those are definitely effective, have been demonstrated to be effective at stopping COVID-19. But there's sort of this other issue, if we're talking about COVID-19 specifically, which is that there is, to this point, this has been studied like crazy, and to this point there's little to no evidence to show that one person can get infected from another person in a different room through an HVAC system. Little to no evidence that shows that it can travel through an HVAC system and infect another person. It seems like all the studies show to date that the mode of transmission is within a room from one person to another. And that's another way in which GUV is more effective. If we apply it in the upper room configuration, that's the most tried and true way of applying this technology to date. That can be very effective at stopping in-room transmission. And so, I'm not going to say that these ventilation measures, putting in a better filter or increasing your ventilation rate, I'm not going to say it doesn't work at all for preventing the spread of COVID. But when we have this new information that the spread is really happening from person to person in room, it indicates that some of these ventilation measures are not as effective if that's the primary mode of transmission. And if we're talking about COVID-19 specifically, I need to caveat that other diseases out there, tuberculosis is one example, there is evidence of through HVAC system transmission.
And I'm going to throw it over to Jason here in a second, but just going to give you guys a little side for my waste business. Have you ever seen like a whole bunch of dirty commercial building HVAC filters? That is a sight to see. Okay. Those things are absolutely disgusting. Like that should be treated as hazardous waste. I'm not kidding. Maybe biomedical hazardous waste. They are absolutely revolting. Now, maybe this one job where I couldn't quote it, but I had a look at it, and maybe they hadn't changed them in 10 years or something, but that is something to deal with from that industry, is how to get rid of those old filters. It's not something that is well known, so it's a problem. Jason.
Like its own little ecosystem.
Oh, God, they're disgusting, dude. Those things are absolutely disgusting. Greg, you want to throw another question out here?
Yeah, so going back to the paper you said it's getting published this week, is that right? Or it's in the process? Where are we at with it?
It's officially published. It's being presented. We weren't allowed to share it until it was presented at the conference. It's being presented today, in fact. So it will now be out there. Yep.
Fantastic.
Good. And when will people be able to read it or see that themselves, and how will they be able to?
We actually have a website under the Department of Energy for our GUV research, and we'll be posting it there. I don't have the actual web link
That's fine.
off the top of my head, but if you Google it, you should be able to find it.
And how did you guys, I see a little paragraph on it, but how did you guys get the information that you put in the paper? What was the process like for that?
It was a deep dive literature review, basically. So we went and dug up all the studies that have been done on this. Some of them, go back quite a ways, and some of them much more recent. There's just been a flood of research on this topic the past couple of years, and we really dug in on them. And what could it tell us about how this technology compares to the HVAC measures in terms of its effectiveness and energy use? And so the study, the paper we're putting out, basically summarizes all of those, all the research we dug up, and also present some other information like, what do we see as some of the limitations from the research we dug up? What do we see as kind of the needs and next steps going forward? And we're kind of using it as a launching off point. We've got a bunch of new work that we're planning for the next year that is all really around further validating, quantifying, characterizing the opportunity this technology provides compared to HVAC measures, and then we'll use that to hopefully educate people about the opportunity, and we'll see if people will adopt it more in buildings, because it's a huge energy savings opportunity.
Jason, when I was reading your bio, I really like this idea of the calibrating measurement equipment and testing guidance for ultraviolet. What are you testing? How are you testing? Is there something simple? People blah, blah. Tell me about the testing and let me know where you're at, and we'll just talk about that for a while. Just start talking about the testing.
Yeah, so we're starting with testing. Are you familiar with the caliper program from its heydays with solid state lighting?
Yep, I'm aware of it. Yep.
Yeah, and so basically this is kind of reviving the program, applying it now to germicidal ultraviolet. And for those who are not, all that familiar, some people refer to it as kind of the consumer reports style testing that we had done, where the idea was to, obtain products semi-randomly. If you can get them in a store, then get them in a store, for instance. Otherwise, you get them through distributors. And we used to do the secret shopping approach with distributors, which was kind of fun. We're taking a little simpler approach now, but we're not doing the testing in-house. We're using commercial labs to do the testing. So we're not looking to compete with the commercial labs that are already out there. We could, in principle, use some manufacturers' labs because they can, demonstrate that they're effectively independent of the sales side of things, right? And so they could, in theory, in principle, test competitors' products and do so fairly. that said, we're at least for now in aligning with precedent, for the program, just using independent commercial labs to do
Mm-hmm.
our testing. And so, yeah, it's been interesting. Just one thing that we're going to be releasing 2 reports pretty soon here once our testing is finished. A test report like you'd usually see from Caliper, just showing the performance of each of the products that we've selected for this round, and then comparing with their, the claims, the rated performance. And then there will be a companion report that gives kind of an overview of what the current standards are that you can bring to bear for testing, that you can use for testing, as well as what are the current capabilities for labs to do the testing. And just as just one example, for testing lighting products, you can use integrating spheres to get the total output. And these spheres can be really big. You can walk into them, or they can be really small, just to measure, say, like an LED. For GUV, we're finding there's very little out there in the way of spheres, and little is a good word. The only one that we have access to through one of these labs is a 20-inch diameter, roughly, and it's actually a hemisphere, not a full sphere. So for the nerds out there, it's kind of interesting to see, what's available, what's not, and see this all evolve.
Is there any pre or on-site post testing that you can do? I remember when you can have a mold test done in a house where they test the mold level in the air outside, and then they test the air inside, and it'll tell you the difference between the outdoor air and the mold in the home, and if there's a serious issue with mold spores in the air. Is there anything that we are looking at where you got to remember, Greg and I are sales guys, okay? So we're out in the field. And there's nothing better than, hey, I have this strip, I remember this guy, Table Charm, came to my house and sold my parents a set of plates, and he threw the plate across the room, and it didn't work. It didn't break, right? So, there's nothing better than an on-site test where you can show people pre and post. We're going to do this classroom for you, and we're going to compare the air in this classroom before. We're going to compare it after. Is there any? Are you guys looking into that at all? Sort of field tools that can help people that actually work?
That falls under our Gateway program, which also goes back to the beginning of our solid state lighting program. I might let Gabe expand on it, though.
Well, there is an absolute need for some type of post-installation evaluation to ensure that what you've installed is actually going to work. I'm not sure that we're ever going to get some kind of test like you're looking for, which is going to, compare something pre-installation and post-installation and show some impact, because that's just going to require specialized equipment. I just don't see that ever being scaled beyond kind of the research community.
Mm-hmm.
But there's absolutely a recognized need for kind of post-installation guidelines. And I believe that there are some groups that are working on that kind of thing. And I think the way it would work is that you'd have some kind of meter that's going to basically measure the irradiance in the space that you're trying to disinfect, and match that up against some design guidelines or standards that say you should have this much irradiance in order to have this amount of disinfection. So that doesn't exist yet, but I think it'll come in the next couple of years.
Well, Greg
And our
bought one
focus,
on Amazon for $10. Didn't you still have it in your car? Don't you, Greg?
Didn't do that. Running right now. No.
Sorry, Jason. Go ahead.
I was just going to say that our focus is on the radiometric side of things, and so we're not planning on in the near future measuring log inactivation rates for different products. Really just looking at what is the irradiance that's produced throughout a space, sometimes simulated, sometimes measured, right?
You know what? So does it work? Does it not work? That's the question. Right? What does the customer want to buy? Well, I'll throw a wrench in that, spokes, right? Because, you think people actually want to buy disinfection? I'm not so sure about that. I think they want to buy disinfection theater. I hate to say it that way. I know it sounds crazy, okay? But, in talking, like, not anymore, but for about 8 months, I talked to a lot of private schools and I talked to a lot of people in Toronto about, I spoke to Van Leerop over in the Netherlands, and he's an expert in UV, and he was saying, yes, it works, and this is how you do it. And he explained it all to me. We used a Philips catalog from 1985, which laid it all out by square meter. And but you know what? When I was talking to the people, it often came up, how do we know? How can we show the parents? And so what they were really looking for was like a machine or some light fixture or some device or whatever, but that had like a light on it or something that they could point to. So, yeah, that's an air disinfection thing there. See, there's no COVID here. You know what I mean? That's really what they actually wanted to buy, was the theater. I hate to say that, and you wouldn't believe, I said this before. I got so much criticism. We don't get a lot of we don't get a lot of comments. We only get criticism, and that was, you only want to sell theater. But actually, I wasn't saying that I wanted to sell something that didn't work. What I was saying was that's what the customer actually told me they wanted to buy. When they take the parents through the school, they wanted to point to something in the classrooms and have like a little light. And yeah, we turned the switch on and now we're disinfecting. See? Isn't that awesome? No COVID here, right? That's kind of what that is what they wanted to buy. They didn't ask me if it worked. They just assumed it worked and that it would do something and they had to maintain it once a year or something like that. That was all part of it. But what they wanted to was, how can I point to it and have a green light that says disinfecting, currently disinfecting or whatever. Like, that's what they wanted, Gabe. And the industry just doesn't seem to want to grab that theatrical part of the sale. And if I had that, I would have sold a lot of, maybe I might have sold a lot of these, put it that way, into schools.
I think you're right for applications like schools and restaurants and retail facilities where people are going to look for that kind of thing. I do think that there are going to be people looking for the actual reduction in illnesses and the numbers that go behind that. It's hitting people's pocketbooks, businesses' pocketbooks. So there's estimates that COVID-related absenteeism is costing businesses in the U.S. $1 billion a week, and has been since the pandemic. And this is going right to their pocketbook. And the evidence is starting to come out that this technology can actually reduce sicknesses, and will translate that to absenteeism over time. And I think once that happens, people will be adopting it for that reason as well.
Well, the UV guys have known that this works for decades. This is not new. The idea of active or passive air disinfection is not new. They did it in the 70s in tuberculosis wards, and it worked. We know it works. So I wasn't saying that I was going to do something that didn't work. I'm assuming that it works. I think that what people want to see, the consumers want to see, the buyers, the people that have the money, they want to see some sort of signal to them that it needs maintenance. It's off or it's working on the device, on the wall, so they can see it and point to it and see it. When that red light goes on, we have to change the bulb. Oh, okay, great.
What about safety? Are you concerned at all? What are you hearing or seeing out there with regard to people being maybe afraid of this technology because they're worried it's unsafe?
Well, that's Greg. How many people bought those crazy robots from you and used to plug them in right in front of you and stuff like that?
Yeah. So I don't think the safety is a concern. I think it's just they don't know. And and to Mike's point too, like, if I had it, I would like to know that it was on and it was working and it was doing what it needed to do, even if it's just a light saying that. And I haven't seen anybody come through with that.
Yeah, but what I'm saying, so on the safety issue, there was just a touch of hysteria in March 2020, April 20, just a little touch of hysteria out there. So people were doing crazy stuff with these wands and everything else, right? And robots, and that kind of faded away, thankfully. I think surface disinfection has its place, Jason and Gabe. I just think it has a very small place and a very niche place. Hospitals, like, airport washrooms that are, whatever, places like that. But to me, when we talked to Fred Van Leerop, he was convinced that passive air disinfection and active air disinfection, which is where you have a device in which the UV light is actually sealed from all other areas around it. The air goes through it, is disinfected, and pushed out the other side. There's absolutely no risk of damage from the UV light to any individual, because it's completely contained in an air tunnel. So like water, all of the municipal water you drink, folks, is all disinfected with UV germicidal UV. And they know exactly how many liters per minute needs to go by and how much UV radiation they need. And they got, believe me, every single town listening to this, there's some huge tunnel that all the water goes through and it gets smashed with a ton of UV before it goes into the pipes. Okay? We can do the same thing with air. Just the water guys are saying, well, you don't have any metrics for how much air is going through and how fast, and you're not testing it. And it's not like everybody gets their air from a tap and they pour out their air and drink it and this sort of stuff. And so there's a belief element to it. But I'll tell you right now, active air disinfection, when when it's maintained properly, or passive air disinfection, the problem with passive air, as Jason said, is that deterioration of the paint, or if you're in a train station, you could wreck the ceiling designs with the UV hitting it. But active air disinfection, where you have a device that sucks the air through cycles the air through a tunnel where you have a certain amount of UV, it will it will deactivate everything that passes through it. Planes, that's why planes have the cleanest air. They clean their air with UV light. I guarantee. I don't know that for sure, but I guarantee. I can almost guarantee you that every plane has some sort of UV disinfection system built into it. Boeing and Airbus, I guarantee you, and Bombardier and the rest of them. It has to be. So why can we not deploy this? No, but the air in planes is clean. I don't know what they do with
the HEPA filters.
HEPA filters. Oh, there we go.
Yeah.
So we need to get that active air disinfection on the counters at distributors, and so they can be screwed onto the wall and wired in, and off you go. I don't see why that product. There's some out there, but I don't see why, or combined into a 2x2 fixture or 2x4. There is some stuff out there, but the problem I have with those pieces, Gabe, is that it's an LED, and I don't know the maintenance schedule on that LED for the UVC. That's the problem I face with selling that particular piece of equipment. How long does the UVC radiation last on the LED?
Less than a year.
Yeah.
With the current products. Yeah.
Yeah.
Jason, do you want to tackle this one, or you want to say anything about those room cleaners, or?
I think I could say maybe just quickly, as far as the longevity goes, there is some data showing that there are, at the chip level, you're seeing degradation for some of these sources dropping down to 70%, or less within a couple hundred hours. And so that's not a guarantee of what you're going to see in practice, but it definitely raises eyebrows. And we'll be doing some of this testing ourselves. We're not going to do live testing, but we may test to say 1,000 hours, and we're starting that now. So that's basically underway, and so we'll have data soon. As far as the contained units, it's definitely correct as far as you're eliminating the hazard for people in the room from UV. If you're containing the UV, you got to make sure you place those things properly. And then I at least have not seen reviewed data on their performance, so I can absolutely see where there's an analogy there with water, but yeah, I'm not familiar offhand with their performance compared to other technologies. So maybe that'd be something we'd consider in the future, maybe.
As a customer, as a person that sells products, replacement products to people, my reservation with the like you said, the contained products with the LED is that I knew it would fade. There's no chance that thing's going to work forever. If it's sucking air across a thing, it's going to deteriorate. And then why not go back to the low pressure mercury? Why not use a tube in there with a known maintenance schedule?
A year. Yep.
Yeah, a year. Change it every year. Yeah. Just like your water system.
The issue with those, it's the issues you're already raising. Is people don't know how well they work. They've got to be really well designed to be sure they work for the applications they're being put in, and that somebody has calculated that airflow and making sure that you're getting the right dosage of the airstream to actually disinfect. And there's all kinds of snake oil out there for sure in that product category, and no standards, no rating system to be sure that you're getting a good product. I do think that that'll come along at some point, but I do the sense that we've gotten is that there's a lot more skepticism about how well those types of products actually work compared to the other strategies that are being considered, the upper room and direct irradiation. We haven't even got into that yet, but that's a whole other way to deploy this.
Okay, well, go ahead, Greg, but we got to get into that other way.
No, I guess from kind of bringing it back to why you're on the show, what is your guys' goal with the paper? Why is PNNL involved in in figuring this out?
Well, we're a Department of Energy lab, and I think we've uncovered that this is a potentially massive energy efficiency and decarbonization opportunity. Our HVAC systems use like the most energy of any system in commercial buildings is like 30 to 40%, and that's gone
Mm-hmm.
up from the pandemic. It's taking us backwards from decarbonizing buildings, and here we've got this new technology that, well, it's not new, but new interest around it that can save a ton of that energy compared to the ventilation strategy. So that's really, I think, the
Okay.
main driver for us being involved. I think
And then what do you? Oh, go ahead.
there's also, we haven't gotten into it, but there's the GUV technologies traditionally have been this low pressure mercury, very old source, and we've got these LEDs coming on, and there's a lot of predictions that's gonna potentially be save 90% of the energy of GUV versus the old low pressure mercury sources. So there's also energy efficiency opportunity there.
What a great place to start off on the sustainability piece with replaceable components and GUVC. What a great place to start. Like, let's standardize these components now, how they connect so people can buy an UV LED chip raise and put a new one in every year or whatever it needs. Like, that's a great place for the industry to start because there's absolutely no chance you're going to get past a year or 2 years with an LED doing disinfection. I know that from the water guys. Remember we had them on back in 2020 or whatever. They had a bunch of water guys. They said the LED, the problem with the word LED in disinfection is that people are associating it with super long life. And he goes, it doesn't work like that. It's an energy efficiency play, and that's it. And maintenance is probably on a similar or same schedule. They weren't aware yet, but it probably once a year you're going to be changing those LED lamps out. It's a pure energy efficiency play. It has nothing to do with the lifetime of the light source. And I can't remember that guy's name. He was a good guy, though. Anyway, what's this other thing you were talking about earlier, Gabe? Or Jason, you want to jump in here? But I want to get to that other thing I don't know about yet. What's that, Jason?
I think just one thing to throw out there, just because it popped into my head as you were talking, is one benefit of LED is that you can pretty much drop kick it and it's not going to break. Whereas you've got other light source technologies, they can break in shipment, as we've experienced ourselves. So no, that's all. Go ahead.
All right, we'll talk about this newer application. So the way this technology has been applied historically, as we said, was with low pressure mercury sources. It's basically a fluorescent lamp without the phosphor coating. It emits a peak wavelength of 254 nanometers, and we know that's very effective at neutralizing all these pathogens. We also know that it causes temporary injury to the eyes and skin if we're exposed to it, and so we don't want to be exposed to it. There are some newer sources out there. Krypton excimer lamp is one type. LEDs can potentially also do this, that emit what's called far UV. This is a lower wavelength, 222 nanometers. Also been shown to be effective at neutralizing pathogens, viruses, bacteria, and so forth. But research demonstrates, I guess you could say it's proven because it's been adopted by standards, that it does not penetrate the eyes and skin like the 254 nanometer, and does not cause temporary injury. And so the threshold limit values for that wavelength that are specified by the ACGIH, I think I have that right, are much higher for that. And so therefore, this is already being sold by some mainstream manufacturers out there. This technology, what they're saying is you can actually embed this into LED light fixtures or light fixtures and just flood the room while it's occupied with this disinfecting UV at all times. And that would be incredibly effective at killing all these viruses and bacteria on surfaces in the air, and would not cause harm to people. A lot of people are saying this is the future. This is where we need to go. And I will say there is some debate out there as to whether that is tested enough and proven enough. But that's out there, and so that's referred to as direct irradiation. So you're directly irradiating the room with the people in it.
Yeah, I mean that's already done in hospitals quite often in the operating rooms. I don't know if they're using that particular nanometers of UV or whatever, but that very serious, high maintenance, highly skilled maintenance people in an environment where you can afford to buy a $7,000 light fixture. Um, I think that that has an application. I don't think we want to look for unintended consequences for something like that. I would urge the industry to be very, very careful about the general deployment of that. Hospitals and these kinds of places where you have an engineer runs the hospital, Jason and Gabe. You know what I mean? The guys, you have very serious maintenance people there. They're going to look at it, find out how it works. How do we deploy it? Do we need controls? All this other stuff. In an apartment building or these other applications where you start to go down in knowledge level of the people that work in the place, you want to be very, very careful deploying that kind of technology. I don't think it's a good idea. You don't know how often it'll be on, or if it's going to be. I just don't think it's a good idea. So I would be, I mean, right now, I mean, maybe in 10 years there's going to be some, but even so, I mean, even 2 years of rats under those lights and the rats are still okay, Gabe. So let's deploy it. Yeah, I don't
Well,
know.
and then just the worst case scenario of somebody saying, yeah, our product is far UVC, when it's not, and it actually is some sort of other UV that's more harmful, and then you have problems as a result. So I think there's you always have to keep that in mind. In the case of upper room GUV, there's the chance you've got maintenance staff that are not trained. They go up and unwittingly expose themselves, and get treated directly, up in that space. So there's that chance with that kind of a system. With the direct irradiation, there's a chance that people don't actually know what they're buying, and they get it wrong.
Yeah, that's why, airports, like places that have very highly qualified maintenance teams, an airport, Grand Central Station, these areas that are, that would have, engineers on staff and stuff like that, Greg, you know what I'm talking about. There's some places
Mhm.
you enter, you can rip out all their lights. You could send in an unqualified guy and no one's going to check anything. Right? Not that I've ever done that, but and then you go up the level, and the higher you go, the more paperwork you have to provide, the more insurances and licenses and training and all this kind of stuff. And when you start to get into airports and all this, you're doing security screenings if your people are in there, and so you're getting to a higher level of compliance just to be allowed to work in the building, Jason. And so there's areas where there's education, there's like your people have to do a 2-hour orientation before they're even allowed to work in the factory. Like it's 2 hours of training of this is this, don't go near this, never touch a crane, da 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 da, all this kind of stuff before you're even allowed to work in the place. So I think there's levels of real estate where compliance for contractors and people that work in the building is way higher, and the knowledge base is way higher. So I think there are areas that we can deploy the passive air disinfection, and where we can use some of these things. One of the like airport bathrooms, you could have a reverse occupancy sensor when you go in that stall, and it blasts the place with UV when no one's there, and when you're gone, it doesn't, and it's this other type of UV, and so even if it didn't work and you got blasted with it, it's probably not going to do much for you if you're in there for 10 minutes. I mean, those kinds of applications I think are good.
I was going to say you want to make sure it's fail safe, no pun intended.
Yeah,
Um,
yeah, for sure, for sure.
I, I think you're hitting on a hugely important issue there about really proper installation, operation, and maintenance, and having a
Mhm.
trained workforce for that. And it's not just with this new far UV stuff; it's with the traditional mercury-based products. And it's
Hmm.
only going to take a few of these bad stories to really stymie this technology. And some of that's already happened. There was a university in New York State uh, where the low pressure mercury upper room fixtures were actually installed upside down, and they were shining down into the professor's eyes and face, and she was burned by them, and this made various headlines across New York State. And these kinds of stories, that gets out to parents and
Hmm.
of elementary schools. This is the thing I'm worried about safety. And so I feel like the deployment, it's going to be hard to control it in this way, but the deployment of this technology really needs to be done very carefully, and we really do need to make sure that we've got people who are trained to install it and trained to operate and maintain it, so that we don't get these these bad experiences.
Yeah, I'll give you an even closer to home one than that. Okay, so F-32 black light blue, you know what that is, right, Greg? BLB,
Yep.
right? You know what an F-32 BL is, right?
Yep.
Right? So that's a UVC bulb for curing stuff in the print industry. Okay. The BL is actually cheaper than the BLB. I don't know if it's still that way now, but guess what? Went mini golf in that, what do you call the nightclub mini golf and thing? And the place was filled. I can tell the difference immediately between as soon as I look at it, I said, that's not a BLB, that's a UVC lamp that they've installed in the fixture. And now every time the kids go in there, they're flicking on the lights. Now, I don't know how much radiation is coming down from 24 feet, but half the lights are black light blue, and the guy bought the wrong box from the supplier because nobody knows the difference between black light and black light blue. And they put a bunch of these BL lamps in there, and whatever, it looks purple, kind of looks cool, kind of looks like a cool thing. And the kids are going in there playing mini golf. And the adults too. And I told the guy, I said, dude, those are not safe to have in here. No, they're fine. What are you talking about? Whatever. Right. But I mean, yes, there is a problem where, that's where I said that it's a good opportunity to standardize, maybe make different sizes of these things and stuff like that. So they can't even go in general use fixtures. It's not even possible for that to happen. It's a great when we're on the threshold, it's a good opportunity, Gabe, to knock heads together. But you know what the problem is? Sometimes we shoot ourselves in the foot. And sometimes we shoot ourselves in the head, right? Like we've shot ourselves in the foot. Let's not shoot ourselves in the head here. How do we get this thing really rocking so, Greg can sell $1 million worth of UVC a year? How do we get there? That's like where the threshold becomes a little bit scary,
Yeah, that's what I'm worried about is people a little bit less educated than Greg selling $1 million worth of these without being educated. Yeah.
Oh, there's people that have sold $1 million worth of these things that have no idea what they sold or where they went. That is already for sure. That's a time bomb out there. Some of those things that, training and whatever, people monkeying around with them. Who knows what they're going to do? Those things, you know what? I hate to say this, Greg. There should be a recall on. So you should call the customers and remind them or something. Hey, that thing is really quite dangerous. You want to make sure that you know how to use that thing, that thing you're pushing around. But you know what? Like I said, sometimes you shoot yourself in the foot, sometimes you shoot yourself in the head. And a good innovation has to pass us by because it wasn't managed properly in the beginning. Final note: if you're listening to this, folks. Everybody wants to go to university and wear a tie every day and stand in an office and tell other people what to do. I think all the good jobs in the future are coming to these controls integrators and to these people that can work in buildings and actually do work and commission and install. And I think there's so many wonderful jobs. I don't know what you guys think of Pnnl, but so many wonderful jobs coming down the pipe for people to earn a lot of money and make a good living. Working practically with these great new technologies that we have at hand in the business. And, I don't know if there's a school for controls integrators or there's a school where people can go to look at this stuff, but there really should be, Gabe.
I totally agree. We need that, and I think we're going in the wrong direction from what I've been hearing in the trends, and those industries that the trade industries are hurting for people right now. So
yeah, that's the time to jump in, kids. Yeah, because you know what? A lot of people glorify the suit, but sometimes if you actually build something, it's very rewarding. I'll tell you that. Having a career in construction or even building management, Gabe and Jason, is going to be such a wonderful career, especially to give, like if you're into the environment or you're into the building management is such a good place to be. Any final thoughts for the listeners, Jason?
No, I definitely agree that systems engineering is there's tons of potential in that space, as well as for analytics. And one great thing about ongoing maintenance of a system is you can make sure that it's performing as you expect, and you can help save energy in doing that, as well as making sure that everyone stays happy in the space and that it works as intended. So.
Gabe.
That's all.
Yeah, this is just such an exciting technology. We are at the early days of this, in my view, and it's got just amazing potential benefits for keeping people healthier and safer buildings, and in addition to what we've uncovered, huge potential energy efficiency benefits. And so, I'd just like to encourage the listeners out there to get educated on it, learn more about it. It's got all these benefits. It's also got some safety concerns, and it's just so important that we deploy it in the right way going forward. We're going to need everybody's help for that.
Maybe one more thing. Manufacturers, publish your data, please.
CooperLighting.com, Greg Eric. That's COOPERLIGHTING.com. Failsafe. Tell me all about it, Greg.
Yeah, that's right. And that discussion we had towards the end, talking about safety and the concerns and all that, go with someone you trust if you're going to do this. And Cooper Lighting is a name you can trust, a company you can trust that's going to do it right. They're going to put the research into it. You'll see the link on the website. I'm sure we're going to have it up on screen where you can actually go there, and they have all the research and they publish their data. They have everything you need on it. So if you're going to get into this technology and do it, which as we're talking about, we should, because there's a lot of opportunity there, Cooper's Failsafe brand is the ticket for that. So check out all of their options.
Go to COOPERLIGHTING.com. That's right. And if you made it to the end of this one, another technical update series, I hope you enjoyed it. And you know what? I say that from my heart about all you young people out here. Think about maybe, that systems engineering. That's what it's called. Yeah. Why not? I'm guaranteeing you there's going to be a ton of high-paying jobs. And you know what? Those jobs are kind of good because you do your job and you go home. Right? And you don't have to worry about it. You probably get weekends off and you have a long vacation. It's one of those work-life balance things, especially if you're saving the environment and whatever else is that you're into. I think it's something to think about, folks. If you're just getting started out, maybe take a step back and say, hey, what's this thing happening over here? Can I get involved? Because we're going to need you, and we're going to need a whole lot of people like that. So if you made it to the end of the technical update series, we thank Cooper Lighting, PNL. Jason, last name?
Tuenge.
And Gabe Arnold. Thanks for listening.